Hello and welcome back. Here we're going to be looking at completing the square to find turning points. So we're going to be walking through step by step. So grab a pen, pause the video when you need to, and let's get started. So the objective here is to find turning points of quadratics by writing them in completed the square form. So question is, what is a turning point? So if you know what the graph of a quadratic function looks like, you should know that it either takes the shape of a U shape sometimes, so we'll call that X and that Y, or sometimes it's kind of like an N shape. So we have like a positive quadratic graph and we have a negative quadratic graph. We call this a parabola, and a parabola has like a U shape or an N shape depending on whether the coefficient of x squared is positive or negative. But that's not really the point. The point of this is to figure out what the turning point is. The turning point is quite literally the point where the graph turns. So in this case, it goes from here. So you see that the gradient is negative, and then at this point, it changes from negative to positive. So it passes through this turning point. And then you have another turning point up here. So you see the graph, the gradient is positive, and then at this point, the gradient changes direction. So it goes from being positive to negative, and so it goes through a turning point. So the whole point of completing the square is to figure out what the turning points are of quadratic graphs. So a quadratic of the form ax minus h squared plus k has a turning point at the point hk. So if we go through an example, we want to find the turning point of the function with equation x squared plus 8x plus 7. So what we first need to do with these questions is start off by completing the square. Completing the square enables us to work out the turning points of a quadratic function quite easily. So if I complete the square of this, I'm going to have x plus 4 squared. So again, I halve this number first. And then I need to subtract 4 squared, and then I add 7. So I end up with x plus 4 squared minus 16 plus 7. So that's going to be x plus 4 squared minus 9. So I've now completed the square. That's great. So the turning point, the coordinates of the turning point are, as we mentioned on the previous page, what you have to do to work out the x coordinate is you flip the sign of this number in here. So a plus 4 becomes a minus 4. So that's the x coordinate. And then this number here just stays the same. So the answer, the coordinates of the turning point are minus 4, minus 9. Okay? And that is the answer to that question. So this one here, we want to find the turning point of the function with equation x squared minus 10x plus 4. So we're going to first start by completing the square. So it's going to be x minus 5 squared. And then we need to minus the 5 squared. And then we add on the 4. So it's going to be x minus 5 squared minus 25 plus 4. So that's going to be x minus 5 squared minus 21. So the turning point, again, we flip the sign of the x minus 5 thing. So it's going to be 5 as the x coordinate. And then this one stays the same. So the turning point is going to be 5 and then minus 21. So here we first start by completing the square. So the coefficient of x is minus 1, so we have to divide that by 2. So it's going to be x minus 0.5 squared. So then we need to minus 0.5 squared and then add on 10 to complete the square. So it's going to be x minus 0.5 squared minus 0.25 and then plus 10. So it's going to be x minus 0.5 squared plus 9.75. So the turning point, again, we flip the sign of this. So if we flip minus 0.5, we get a plus 0.5. And then this one stays the same. So that's the y coordinate. Okay, so that's the turning point. This example here, we have a non-monic quadratic, so we need to start off by factoring out the 2. So if we factor out the 2, we get 2 bracket x squared, and then we need to divide everything by 2, so we get plus 2.5x and then plus 6. And then we need to complete the square of what's in the bracket, so it's going to be x plus 1.25 squared, and then we need to minus 1.25 squared, and then add on the 6. So it's going to be 2 bracket x plus 1.25 squared minus, if we do 1.25 squared, that's going to be 1.5625 plus 6. So that's going to be 2 bracket x plus 1.25 squared plus 4.4375. So that's going to be 2 bracket x plus 1.25 squared plus 8.875. So the turning point to this one, we're going to flip the sign of this one, so that's going to be minus 1.25, and then this one stays the same, so that is 8.875. So that's not the nicest number, but yeah, that's the turning point. So here's an exam style question. So it says find the turning point of the graph of equation y equals 4x squared minus 16x plus 9. So we've got 3 marks here. So again, we need to first start by factoring out the 4 to complete the square. So it's going to be y equals 4 bracket x squared minus 4x and then 9 divided by 4. So that is 2.25. So if we complete the square of what's in the bracket, we end up with x minus 2 squared minus 2 squared plus 2.25. So that's going to be 4 bracket x minus 2 squared minus 4 plus 2.25. So we have 4 bracket x minus 2 squared plus 1.75. So if we times it out by 4, we get 4 bracket x minus 2 squared plus 7. So the turning point, we are just going to flip the sign of this and keep this one the same. So the turning point in this case is going to be 2, 7. Okay? So here are 4 quick fire practice questions on finding the turning points. So we need to work out the turning points for each of the following quadratic functions. So have a go at these questions and I'll reveal the answers in a moment. Okay, here are the answers to those questions, so well done if you managed to get those all correct. And that's everything, so well done for today. If you found this helpful, feel free to check out some of the other GCSE Maths videos, and I'll see you again soon in another video. Bye!